Hello everyone. Welcome to my YouTube channel Trance. Okay, so today I have an amazing video for you, right? We are going to look at a proof of a magic. Exactly, a card magic. Okay, so just see this video first and then I'll get on to the proof. This magic is very interesting. Okay, before I explain it to you, could you guess what could be the concept before I tell it to you? Just think. So let me flip the cards. 1, 2, 3, 4, 5, 6, 7. Right? 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Okay. So I'm a lovely person, so I'm gonna choose Ace of Hearts. Right? So let's see. So currently I'll point out to this pile, right? And then again 2, 3. Just keep an eye out for the Ace of Hearts, right? This is the magic trick which you can perform as well. Okay, so I'm gonna next choose this file, right? Okay, okay, one more time and then we are done. And I know exactly it is in this file. Okay, this is the third time we are choosing, and now the final magic will begin. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is your card, the 11th one. Okay, rest I'll explain it to you in the video. Catch you later. So I hope you have seen the video, and if you've guessed correctly, before that, did you like the magic or not? Okay, you can try it out by yourself. Okay, it's a good magic trick. Good card trick, in fact. Okay, so I think some of you might have guessed it correctly. It is related to modular arithmetic, right? So, what is modular arithmetic? Let's get to the screen to find out. Okay, so hope you can see my screen, right? So, modular arithmetic basically is, suppose it is just like talking about remainders, right? See, suppose 7 when divided by 3, what will be the remainder? 1, right? So you usually write this as 7 is congruent to the remainder mod 3. Okay. Similarly, suppose I wanted to write when 15 is being divided by, say, 8, then what is the remainder? So I'll get 7, right? So 15 is congruent to 7 mod 8. Okay. So this is the number which is being divided. This is the number with which we are dividing, and this is the remainder. Okay. In other words, it also means that 15 minus 7 would be divisible by 3. 8. Okay. It would be divisible by 8. Okay, fine. So how how does modular arithmetic come into picture here? Okay. So at the start, suppose these were are, how many are these? 3, 5, 7, right? So these are 7 into 3. So 3 piles of 7, which means we have 21 cards. Okay. Now it's important that the number of cards must be odd. Okay. At the end of the video, I'll ask you a question too. Okay. So suppose I am choosing this card. Okay. So let's label it. So when we number it, I'll do it 1, 2, 3, right? And this will be 4, 5, 6, right? So suppose we have chosen this card. So this would be how much? 1, 2, 3, 4, 5, and 6. So this must be 18th card, right? So currently it is in 18th position. Suppose we are choosing this card. Okay. Now, what does the magician do? He he would keep this pile in the middle. Okay. So now when the first time when you point out the pile, so this is the first time. Okay. When you point out the pile, so this is the configuration. Suppose we have chosen 18th card. Okay, so this deck will be in the middle. So let's take this deck at the very top. Okay, then comes this deck. So currently my numbers are like this. Okay, so I'll be having 1, then 4, then 4 plus 3 is 7, then 8, uh, 7 plus 3, 10, 13, 16. How many are there? One more. 19, right? Okay. So this is these are first 7 cards that will be placed. Okay. And how will you place it? In this order: 1, 4, 7, then comes 10, 13, 16, then comes 19. Now the important pile comes. This pile, which is in the middle. Okay. So it has table of three. So 3, then 6, 9, 12, 15, 18, 21, and yes, we are done. 2 here, and 3 here, right? So currently, next file in which 18th is here. Okay. So it was obvious that these these 7 cards, okay, these 7 cards are like wasted. They are just, wasting the position. Now, therefore, your card must be in one of these 3 piles, right? And it is supposed to be one among these 3 piles. Okay. Now later on, the rest of the cards will be placed here. Okay, rest of the 7 cards. But I have, as we have made pile like this, and I have made you choose like this. Next pile that you will point it out to will be this one, right? So whatever pile you have chosen the first time, okay, so your card can be in this row. Okay, I'm just talking about the row. Can be in this row or it can be in this row. Okay, fine. So what does it mean? Just let me highlight. So after the first piling is over, or the first selection is over, your card must be among these 3 piles. Okay, so we already have 6 cards above it, right? And it can be in any of these 3 piles. Now, what does it mean? Now, this time, if we have to choose this pile, right? Because the one who has chosen the card will say that my card belongs to this pile. So now see, this card is currently at 5th position from the top, right? So when I distribute the cards, I know that some 7 in the next distribution. This is second time that we have chosen, right? We need to do this 3 times. So there will be 7 cards here. right? Now, after this, our cards will come from this pile, which will be 110, 9, 110, 19, 9, and 18, which is fifth in the position, right? So 1, 2, 3, 4, and 5, right? This is card number 18, okay? And the rest of the cards. Fine. Now you'll see that if you check this pile, the third time when you point out the pile, okay, this card is here, which is exactly at the middle, okay, which means from the top it is at fourth position. What does it mean? It means that because this pile is going to be at the center, so there will be seven random cards. Then after seven random cards, fourth card will be your card. That is 11th card. Always, right? So in a deck of 21 cards, if you do this process of choosing the pile three times, then when you again get the deck back, so after piling up the decks, 11th card will be your card. Always, right? So why does it happen? Okay. So I've been explaining it a little bit from the start, but now let's do it formally. Okay. So 1, 2, 3, 4, 5, 6, 7. So obviously, now I will show you the modular arithmetic behind it. Okay. So this is the first row and this is the seventh row, right? The only thing that matters is in which row is your card. Okay. So suppose you randomly choose any row out of seven. Okay. Once you have chosen this row, for example, let's say this is some sixth row. Okay. Your 18th card was in the sixth row, right? It was here basically. Because this file will always end up in the center, so we are not worried about the column, right, in which uh, this will be placed. Okay. Once the position is fixed, sixth, so next what happens is, this is the first time. Now second time when you distribute, you know that seven cards will be placed like this. Okay. Now your card can be now among any of these seven positions, right? So what does this mean? So these are the possible positions for your card. Okay. When you place them second time, right? Now suppose, let's forget about the sixth. Six was just for an example. Now suppose your card was in this position, right? Which is either you have selected first two cards, right? Among any one of them. Okay. If your card was among this, suppose you have chosen the first card. Choosing first card is same as choosing the second card, right? Because from the top it is at the third row. That is what is important. Okay. So if you have chosen this card, then if it belongs to the third row, right? So then in the next turn, what will happen is seven cards will come before it. Okay. Here you have chosen once. Here you have chosen the pile second. Suppose I am choosing this. Okay. So first seven wasted cards are there. Now, because your card is the third card, right, from the top. So 1, 2, 3. See, this time it ended up at the center position, right? Why is this center position? Center position with respect to the column, right? If this is the column, it ended up at the center. Now he will again choose this pile, and obviously it is at the center. So 7 plus 4, right? These are 4 cards, right? Yeah, this is the fourth card, and obviously any one of the pile will be at the top. Suppose this pile will be at the top. So 7 cards from here and fourth card. Okay. But now, what if instead of doing this, you chose the bottom row? Okay, so let's examine that. Suppose you would have chosen the card below it. So 1, 2, 3, 4, 5, 6. These 7 cards, right? Now, instead of choosing the first 2 cards, suppose you have chosen the card at third, fourth. This is third, fourth, or fifth position. Okay. Let's all the positions are same, right? Because we just need that it is in the fourth row from top. Okay. So if you have chosen this row, any card from this row, suppose I take this card for example, or maybe let's take this card. Okay, corner wala. Okay. Now 7 cards will come from any one of the pile, right? So let me draw the 7 waste cards. Now see, your card is already at the fourth position, right? So see, your card will come. It is the fourth card. So this is the first card that will be placed, second, third, and fourth. Again, it came back to the fourth row. And that is exactly what we want, to end up in the fourth row. Because as soon as it ends up in the fourth row, it will be one of these cards. Okay. And then whichever pile the guy chooses, suppose I choose this pile, that my card was in this pile, then you know that certainly this is your card, right? Now, what if I would have chosen the card from the last row? Okay. This configuration is after the first choosing. Okay. After the first time you have chosen your cards, right, and shown up the pile, this is the second time I place them, and now you have to choose the pile. And that is what I'm extending. So suppose you have chosen a card from this row, right? The last 2 cards, or, or the last two, or the sixth or the seventh card from the first selection, right? So currently they are in fifth row. Okay. Now suppose I have chosen this card. Okay. So again I'll pile it up. So 7 wasted cards will be there. Now see what happens. So this is the fifth row, and suppose this is one. Because it is the fifth row, it will be the fifth card. So 1, 2, 3, 4, and 5. Again, your card come back at the middle. Came back at the middle. Okay, which is fourth row, right? And then when you again pile it up, you know that this is the fourth card from the top. Suppose I pick this pile at the top, so 7 cards from here and 4 cards from here, which gives you the 11th card. Okay, so this is the mathematical proof behind it. Okay, so now I hope you like the video, but before going, just a tricky question. Can you do this same trick with 6 cards of, say, 3 piles? Can you do the same trick? If yes, then how? If no, then how? I would be eager to listen to your answers. What about 5 cards in each pile and 5 cards, and we have 3 piles, right? And in both the cases, if it is possible, then which card will it be, right? So do like, share, and subscribe this video. I hope you enjoyed this. Okay. And guys, do go out and share this trick, show this trick to your family and friends, and get lots of love. Okay. Take care, everyone. Today is a special day. I won't tell you why, but it is. Okay. Every day is special, but okay. Take care, guys. Bye. See you in the next video. Love you all. So, for people who are wondering, uh, how or where did we use modular arithmetic, right? So, it is all in the rows, right? Suppose 3, 3, 6, 7. Suppose I let this be 0th row and let this be 6th row. Okay. So, your card's position or your card's rows position is basically mod 7. Okay, it can be anywhere from 0 to 6, 4, 5, 6. Okay, so suppose exactly that's why when we chose the a card among these two, if I chose a card which was at the 0th position or at the first position, the next time when the pile comes, so it will be at the 3rd position, right? Because due to 7 cards are here, so 0th card will come here and first card will come here. So next time your card will have, it would be in the 3rd place, or it would be 2 mod 7, at 2 mod 7, right? Now next when you do this, the same process, it will come at 7 plus, this would be what, 3. So 7 cards here, and then when it will come to 1, 2, and your 3rd, so this will be your card. Now it comes to the 4th position, or you can say 3 mod 7. Okay, whatever card you choose, it will, after the 3rd time, it will be at the 4th position or will be at 3 mod 7. Okay, suppose you would have chosen one among these 3 cards, right? So at the start you would be at 3 mod 7, and obviously because it is already, it came to the middle, so in the next time also when you pile up, it will be 3 mod 7. Okay, what about these two, 5 and 6? So 5 and 6, basically, these are the 7 cards. 5 and 6 just means 1, 2, 3, 4, 5, 6, 7. Okay, so these two are the 5 and 6 row cards, right? 5 and 6th row, or because you are including 0th row as well, right? That is why we are calling these as 5 or 7. So this is what, this is basically, initially it would be 5 mod 7, right? Okay, now after 5 mod 7, it has come to the 5th place. So in the next piling, when you place 7 cards, then 1, 2, 3, 4, and the fifth card. Again, it comes to the fourth position, or you can say 3 mod 7, right? So that's how modular arithmetic came into picture. Okay. I hope you enjoyed this video. Do like, share, and subscribe. See you later in the next video. Bye.